Still working in Chapter 3, Section 1, we have track and field day continued. Each member of a small statistics class ran a 40-yard sprint and then did a long jump. This is the same table of values that we saw before, but our new problem is going to be to describe what the scatter plot in the previous example reveals about the relationship between sprint time and long jump distances for students in the statistics class. Now, before we even look at what that scatter plot looked like, let's just think of a few things. I mentioned before, that we think that if we run faster, then we will jump farther. If we think of that in terms of the measurements we have here, that means as our sprint time decreases, our jump distance would increase. Sorry, this pen's dying on me. So as our sprint time decreases, our jump is increasing because we have one going up as the other one goes down. That should look for us to be a negative relationship. One up, one down gives us negative because they're going in opposite directions. We think that the jumping, or I think that the jumping is going to happen pretty much in response to, that's why we call it a response variable, our sprint time. So it would make sense for that to be a linear relationship. So if we look back at our scatter plot, here's a picture of the scatter plot we had before. We want to describe that scatter plot. We're going to do that using the acronym DOFS, where D is going to stand for direction, O is going to stand for outliers, F is form, and S is strength. I know we've had S be shape, we've had S be spread, and now we have S as strength. So yes, this is different. You have SOCs for one variable, you have DOFs for two variables, direction, outliers, form, and strength. So we were just discussing the direction. Students who took longer to run 40 yards tended to have shorter long jump distances. So there is a negative association between sprint times and long jump distance. And yes, you want to make sure you have that in context. Please don't just say that it's negative relationship. Then moving on to our form. Form, we're looking to see if it's linear, if it's curved, if there's no relationship whatsoever. Those types of things are what you're going to explain it as. To see if it's linear, you want to see, can I describe this with a line? Can I say that there is some sort of line that goes through all of them? If I can explain that pretty well with a line to model it, then I would say that it has a linear pattern. Then for our strength, because the points don't vary too much from the linear pattern, the association is strong. Another way you can look at that is if I, instead of just seeing the line that I could possibly draw through there, if I see if I can draw an oval around it. So if I create an oval around all of those points, I want to see how tight is that oval to being more like a line, or how open is the oval to being more like a circle. The more open it is, the less strong the relationship is. The tighter it is into being a line, then the stronger the relationship. And then finally, we have our outliers. For outliers, you're looking for any point or points, it could be multiple points, that strongly deviate from the rest of the pattern. Now you might see some of them, like maybe this one up here seems to be farther away than the rest of them, higher than we would expect it to be. We would think it would follow this negative relationship and be lower, but it's still pretty well within everything else. If you had something way up here, or even way far down here, although that's still in the trend, the negative trend that we're seeing, it's so far removed in the X direction that that could still be an outlier. A couple things I want to point out. You do not have to write these words on the side. You can just talk about it like you would speak in normal language. Again, with outliers, there's different things called like influential points and that sort of thing that we could look at, but overall you're just looking from deviations from the pattern. So DOFs, direction, outliers, form, and strength, your way to describe the relationship in bivariate data.